Alright, so it's a little evening activity here in the Jarvis household. As you can see, we're downstairs in the Jarvis basement once again for another exciting geometry lesson. We've got little man over there interested in watching the fire and actually wants to learn a little something about proofs tonight. So let's have a seat and we're going to go ahead and get started. Alright, if you have any questions, bud, just speak up. Anyway, we're looking right now, we just sort of finished that introduction to proofs, which dealt with algebraic properties and algebra problems that you were used to looking at in Algebra 1, and being able to go through a proof of how to solve for a particular variable using the properties from algebra. So it was real easy, or hopefully it was a step in the right direction in getting you to understand how to justify your lines with a two-column proof. And then we actually made the segue into looking at segment relationships and angle relationships. So I just want to go through one on the board. Alright, so let's take a look at the segment addition problem I put on the board here. And we're basically looking at given the length of segment AB is equal to the length of segment DE, meaning they're congruent. So the one thing you want to get in the habit of doing is marking off what's given in the diagram. The length of segment BC and the length of segment EF have the same length, so we're going to mark those off congruent as well. And we're trying to prove the length of the whole segments are equal to one another. So as we set up this proof, again, we said 99% of the time, what are we going to start off with? The given. So I'm going to put AB equals DE, and we're going to put BC equals EF. Well, if we're trying to prove that those whole segments are congruent or equal to each other in length, what do you think I need to do with these two pieces? Well, as we look at it, again, if I said this was 2, that would mean this has a length of 2. If I said segment BC had a length of 4, that would mean segment EF has a length of 4. If this was 2 and 4, the whole thing would be exactly 6. Same thing on this segment. If I look, that was 2 and that was 4, the whole thing would have a length of 6. Again, showing that they both had a length of 6, meaning they're both congruent. So what did we just do with the 2 and 4? We added them together. So what do I want to do with these equations? I want to use the addition property of equality, which would let me add two equations together. Add what's on the left together, add what's on the right together. So that's going to give me AB plus BC equals DE plus EF. Just sneak that in there. Now, we at least have these two pieces added together. I want to get segment AC somehow involved in an equation. Well, if you think back, we had all the properties from algebra that we could use, the postulates and theorems that we've done so far in geometry, and the main one being, I think the first big postulate we looked at was the segment addition postulate. Let us add two pieces together to get the whole piece. So again, I could say segment AC is equal to AB plus BC. I can use the same reason for the other statement. Segment DE plus segment EF equals the length of the whole thing. So I can say segment DF is equal to DE plus EF. Again, that was the segment addition postulate. We said we could abbreviate it SAP, but until we get comfortable with it, I'm just writing it out that way. And lastly, now what can I do? If AC equals AB plus BC, then using the substitution property, wherever I see AB plus BC, I can substitute AC in its place. So we're really taking this, substituting it there, and we're going to take segment DF and substitute it in on the other side. That's going to leave me with the length of segment AC equals the length of segment DF, and we just used substitution. Now we're going to take a look at another problem involving angles. I'm going to let it get set up for you. You're going to have to do that for homework, but you're going to do the same type of proof using angles. Alright, let's take a look at this one. This one's similar in the thought process of the first one we did with segments, except now we're going to be working from some larger segments being equal to going back to the smaller pieces. Again, notice what's given. JR is equal to VS. Kind of hard to mark off congruent. What I like to do in a situation like this is put a little bracket with a hash mark in it. congruent or equal to VS. So I'm going to put another little bracket going over that whole thing with a congruence mark in it. Segment JA has the same length as segment VI. We'll put two little marks there. Can we now prove or show that segment AR and segment IS have to have the same measurement? And again, randomly just pick some numbers. If this whole segment had a length of 10, this whole segment would have to have a length of 10, since they're equal. If JA had a length of 2, VI would have to have a length of 2. If this whole thing's 10 and this is 2, then this piece would have a length of 8. Same thing here. If that's 10 and that's 2, this piece would have a length of 8. Therefore, the lengths would have the same length. Or, I should say, those segments would have the same length, making them congruent. Now, in this case, we said that like 99% of the time you want to start off with a given. But I said you have to start to develop sort of a thought process in setting up a proof, and you want it to flow. And I always tell my students, I never like to put anything down unless you're going to do something to it or use it right away. So what do we have to do? I've got to go from the big segment to subtracting that piece to get the other one. So it sort of makes sense as we look at this to think about it and say we have to start off with the big segment. So I'm going to put JR equals VS. The other thing we should start to think about as you develop your ways to set up and solve for a proof, keep it down there, bud, is look at what we're trying to prove. We're trying to prove AR, the length of segment AR, is equal to the length of segment IS. So somehow I have to get an equation that involves segment AR up on the board. Somehow I have to get an equation that involves segment IS up on the board. Then I want to get them in the same equation, and then hopefully get them to where they're the only things in the equation and they're equal. So if I look at segment R, what kind of equation can I get AR involved in? And this again goes back to the segment addition postulate. If I add these two pieces together, I should get the whole piece. So when we look at that, I'm just simply going to say JR equals JA plus AR. Again, what lets me add two pieces together to get the whole thing? Segment addition postulate. Can I use the same argument for the other segment? Why, of course we can. We're going to say segment VS is equal to VI plus IS. Same reason, it's under the same statement. Now again, why did I put that first statement down? I want to put something down if I'm going to use it or do something to it. What can I do with these two lines? And again, maybe grab another color up here. But if we notice here, I got those two are the same, right? I can substitute JA plus AR in its place. VS and VS. I can substitute, let me put two lines there just so you can see that they're, I can substitute VI plus IS in its place. Again, we just used the substitution property. So again, we went through the thought process. Get an equation that involves AR, which we did. Get an equation that involves IS, which we did. Get them in the same equation, which we just did. What do we need to get rid of? I need to get rid of JA and VI. Look what we haven't used yet. Other part of the given. Could I have listed all the given up top? You could have. But I like this because it makes sense to when we do the next reason as to what we're doing. So we've got JA equals VI, other part of the given. Now what do I want to do with these two lines? I need to get the JAs to go away and the VIs to cancel out, meaning I have to subtract them. So we're going to use the subtraction property of equality. And I like whenever we use one of those properties from algebra, addition, subtraction, multiplication, or division, I like to see when I'm using the subtraction property of equality, right above it the two lines that I'm subtracting. I don't want to look at this and say, all right, I have to pick something from line 1 up in the given, which we haven't used yet, and subtract it. I want to say, hey, bam, subtract these two. When we do, what happens to these JAs? Cancel out. I'm left with just the length of segment AR. VIs cancel out. I'm left with just segment IS. Again, what should always be the last statement in what you're trying to prove? What you're trying to prove. It's never the reason, but it always is the last statement. Let's look at something very similar to what we just did with segments, we'll do the same thing with angles. Alright, go ahead and copy this problem down. Again, very similar to the last one we just did, except we're going from segments back to angles. And again, what should be going on in your head? If I have angles, probably angle addition postulate's going to pop up. It's one of the only postulates that we've got dealing with angles thus far. But you can see I've got the two larger angles equal. Angle JAR is equal to angle VIS. I've got angle 1 equal to angle 2. We're trying to prove angle 3 is equal to angle 4. And I bet you can use the last proof as sort of a blueprint as to what you want to do with these angles. So copy that down. Again, try and have that ready for Thursday. Look at this guy here. It is definitely past his bedtime on a Monday night. Yet, we're doing proofs and the boy's wide awake. He's like, show me those proofs, Daddy. I can't wait to get to them. So someday he's going to be doing these just like you guys are doing.